Welcome back to CATIA class. In this video we're going to go over the T extrusion. So if you go to your textbook, you'll find step-by-step instructions on how to create this T extrusion. This is from chapter 8, 4.7 through page 4.46. I'm not going to go through all the details covered in chapter 4. I'm just going to cover the main topics to get this T extrusion completed. Alright, so here's the completed T extrusion. So I'm going to go ahead and open up the L extrusion. So our goal is to take the L extrusion and turn it into a T extrusion. So go ahead and open up your L extrusion file from chapter 3. And let's first make sure we are in the correct unit. So I'm going to go to Tools, Options, Tools, Options, go to General, click the plus, go to Parameters and Measure, go to Units, go to Length, and we're going to be using inches. And OK. Alright, so we're going to take this L extrusion, turn it into a T extrusion, and then we'll save it with the new part file name. So that way we can keep the original L extrusion and create a second file called T extrusion. Alright, so if you walk through the chapter 4 instructions, they'll ask you to create a fillet. To zoom in and out, hold the wheel, tap the right button, move the mouse up and down. Once again, hold the wheel, tap the right button, and only hold on to the wheel and move the mouse up and down to zoom in and out. You can always zoom in using the magnifying glass. And to rotate, hold the wheel and the right button at the same time and move the mouse to rotate. If it's too difficult to rotate, you can always use the command rotate and just hold on to the left button on the mouse and rotate. Okay. Another thing you can use is this toolbar to show isometric view, front view, back view, side view, and so on. Okay, I'm going to hold on to the wheel and the right button to rotate. Alright, so I'm going to zoom in into this corner, not the chamfered corner. So this has a chamfer. Now we're going to learn how to create a fillet in Part Design. First, make sure you are in Part Design. So when you open L extrusion, if it takes you to another workbench other than Part Design, right? Go to Start, Mechanical Design, Part Design. Now we are already in Part Design. If we were to go to Part Design again, it would actually think, CATIA is going to think you want to start a brand new file. Okay, so if you're already in Part Design and you click on Part Design, CATIA will automatically create a brand new file starting from scratch. So we're not going to click it. Actually, you know what? I'll go ahead and click it just to show you what happens. If you're already in Part Design and you click on Part Design, see it thinks you want to start a new file. So I'm just going to cancel. So we're good. We are in Part Design. Alright, so let's learn how to use the fillet command. So fillet gives you a round corner. Chamfer gives you a straight cut. We'll come back later and do chamfer. Alright, so hit the plus sign. You can see the history of how the L extrusion was made. You can always go back to the sketch, double click on it if you ever want to make some changes or updates. To exit Sketcher, click on the yellow arrow. Alright, so I'm going to hold on to the wheel and move the mouse to pan. Then I'm going to zoom into this corner here. Again, you can use the magnifying glass if you like. Hold the wheel to pan. Alright, so I'm going to round this corner. And I mentioned this before, typically chamfers, straight cuts, or fillets are intended to get rid of sharp edges. So anytime somebody's handling this part or is being assembled, being attached or bolted to another part, one thing you don't want is sharp corners that can damage the other part or even harm the technician's hands. By the way, the knuckles, they call these sharp corners knuckle busters in the shop. Okay, so to avoid any damage or injury, we round off the corners. Okay, so we're going to create a fillet. So edge fillet, so click on fillet. Click the edge. And it's hard to see, but it's already given us a preview here of a dimension of 0.197. I'm going to use 0.5 as instructed by the textbook, 0.5. If you use something else other than 0.5, I'm okay with it. I'm not going to take any points off on the assignment if you use a different radius for the fillet. We can click preview. So it's giving us a preview of what the fillet is going to look like. If you're happy with it, you can hit OK. And there's our fillet. All right, now the book or the textbook tells you to create a second fillet on the opposite side. So notice we already have our first edge fillet, including our pad or extrusion. Then we have our fillet. So if we create a second fillet, it's going to remember the last radius that we used, 0.5. And we're going to go ahead and hit OK. There it is. We have our second edge fillet. We can always open this up and change the radius on the fly by double clicking here, so you don't have to open the fillet command again. And one thing I haven't mentioned in the past is anytime you create a feature using the commands, so when we used pad or extrude to create the yellow extrusion, it named it pad 1, and we just did edge fillet 1 and edge fillet 2. Notice it takes the name of the command. Alright, now something the textbook doesn't show is that instead of having to create two separate fillets, you can create one fillet and pick two edges. Okay, so the textbook doesn't show you this, I think because the textbook shows pictures of a limited CATIA license. Yes, unfortunately, if you want some extra options or extra commands in CATIA, you have to pay extra for it. And for us, we do have it on our student license, where we can create an edge fillet and pick more than two edges. Okay, so what I'm going to do is I'm going to delete this one. I can always right click delete, or I can always hit undo. I'm going to delete this edge fillet number 2. Delete it, there it is, but I'm going to keep the first one. By the way, I haven't taught you this yet. If I'm wondering, hey, where's edge fillet number 1? I can always right click on the feature, edge fillet, and go reframe on. So take me to that location. 3, 2, 1, reframe on. Notice there, it takes me to the fillet. I was expecting it to zoom in further, but close enough. So it's highlighting in orange. By clicking it, it selects it. Alright, so let me show you how to pick more than one edge to fillet. Okay, so I'm going to double click on edge fillet number 1, double click. Now I want you to notice, and it doesn't show this in the textbook, there's this little bag that you can click on to pick more than one. So if I click on this little bag, notice there's already this edge, right? There it is, edge number 1. And we can add or remove or replace. Now I'm going to pick the second one. Okay, so now there's two edges we're filleting under edge fillet number 1. Notice the yellow swirl. It's going through an update because we've added a second edge. Okay, so I'm done picking edges, so I can close this sub window here and hit preview. And notice it's going to fillet the second edge. I'm going to accept it and hit OK. Yes, so you don't have to keep clicking on edge fillet when you have multiple fillets. You can just select multiple edges as long as they have the same radius, right? As long as they have the same radius, which is 0.5 in this case, right? 0.5 inches, and OK. Okay, let me zoom out just to show you that we do have two fillets off of one command, right? All right, so the next step is to fillet the back edge. So I'm gonna hold the wheel, hold the button, rotate. Now it instructs us to create a fillet back here. Let me zoom in a little bit. All right, so we're gonna create another fillet. Now this fillet has a different radius. Okay, so if it had the same radius, we could have added a third edge under this edge fillet 1, but this fillet that we're going to create has a different radius. So let's go to edge fillet, select the edge. Now it defaults to 0.5. We're not going to use 0.5. Remember from our sketch to create this extrusion, the thickness was 0.1 inches, and the inside fillet, let me zoom in. This thickness is 1 inch. My mistake, 0.1 inch. This radius is 0.125. So I'm going to take this thickness of 0.1, 0.1 plus 0.125. So 0.1 plus 0.125, and I'm going to hit preview. And there it is. And the reason I chose 0.1 and 0.125, add them together, is to give us this constant thickness of 0.1 all the way throughout. It's like taking a piece of sheet metal, flat piece of sheet metal, and then you bend it 90 degrees with an inside bend radius of 0.125, which is 1/8 of an inch. Okay, so we're good and hit OK. Notice it keeps that constant thickness, except for the chamfer here, but there it is, constant thickness. And I haven't talked about this yet, but we have measuring tools here. So here's our calipers. If I click on calipers, I can click on this edge here. See, it tells me that it's 0.1 inches. This radius is 0.125, and it also gives me the X, Y, Z coordinate of the location of the center point. Okay, so these are calipers. If you want to measure between two surfaces, a line and a point, any distance, you can always go from calipers to measuring distance between two pieces of geometry. You can also select it from down here. But since we're already in calipers, might as well select it from here. So now it's like, hey, let's take a measurement from any piece of geometry to another piece of geometry. So you can say, hey, what's the distance from this edge to this fillet? It gives me a distance. Notice it doesn't give you a distance perpendicular. If you want a distance perpendicular, right now it's saying 0.515. If I say, hey, I want it to go infinite. Infinite meaning forever, right? So if I click on infinite, so if I pick the line again, it's going to take the measurement and give us the shortest distance to this edge. As you can see, it gave us the shortest distance of 0.5. So it's extending this edge for our measurement, give us the shortest distance if this line went on forever, right? Okay, so this is a way to take measurements. If you want to keep the measurements, notice here in the tree, if you wanted to keep it, you can click on keep and hit OK. I tend not to keep measurements because you can end up growing your tree with all this extra information that you don't really need. So I typically have keep measure off, turned off, and I'll just cancel so it doesn't create a measurement in the tree, and then keep this unless you want to, but we don't need it. So I'm gonna make this go away and just cancel. It's gone. All right, so now in the textbook it tells you, hey, you know what? Forget about this fillet. We're gonna instead use a chamfer. Okay, so I'm gonna delete this fillet. Notice how we have edge fillet 1. Then we used to have an edge fillet 2, but we deleted edge fillet 2, and we did double edges on this one. So now this is called edge fillet instance number 3, right? And so on. Doesn't really matter. You can always give it a different name. You can always right-click properties and give it a different name if you like. All right, so I'm going to go ahead and delete this as instructed by your textbook, delete. And instead, I'm going to use a chamfer. So just like in Sketcher we created the upper chamfer. In case you forgot, let me double click on Sketch 1. Remember we created a chamfer in Sketcher. So here's the chamfer command in Sketcher. Let's exit the sketch. So now we're going to create a chamfer in Part Design. So difference is now we're doing it to a solid. Okay, so let me rotate this so we can get the back edge. So we're going to go to chamfer, edge, and let me see what measurement we're supposed to use. I think it was 0.125. Yep, so for our chamfer, we're supposed to use 0.125 at 45-degree angle. Okay, so for our length, 0.125 at a 45-degree angle. Let's hit preview. And there it is. It's giving us a preview of the chamfer, as you can see, showing it to us in orange. Okay, so you have options here. You can define a chamfer by length, angle. So the length of 0.125 is from this intersect point to our new location, 0.125, and at an angle of 45 degrees. Another way of calling out chamfers, you can say length to length. We could have typed in 0.125 for the horizontal, 0.125 for the vertical. And there's other ways of defining your chamfer. Typically the first one is the most common one. Just be aware there's other options when it comes to defining your chamfer size. Okay, so I'll just leave it at length, angle. So length 0.125, angle of 45, and hit OK. And there's our chamfer. All right, so next step is to create holes on this wall. So let's take a look at the measurements of the hole that we're going to create. Yep, let me go back. All right, so we're going to create this hole, but before we do, we're going to pre-select this edge of the chamfer, and we're going to select this edge while holding onto the control key. So we're going to first select the two edges. That way, when we create our hole, when we click on hole command, it's going to locate the center of the hole with respect to this edge and this edge. So we're going to use a distance of 1 for the horizontal to locate the center horizontally, and 0.35 inches from this edge to locate the center of the hole vertically. And then we're going to use a diameter of 0.25 for the hole. All right, so let's go ahead and create that hole. Okay, so let me zoom in into that area. Okay, so I'm going to hold on to the control key on the keyboard. So that's the bottom left key on the keyboard. Hold on to the control button. Click this horizontal on the chamfer and then click on this vertical. Notice how it's red. If you accidentally misclick, let's say instead of picking the edge, I accidentally picked the surface. Notice how when it picks a surface, it turns orange. When it picks an edge, it turns red. So I misclicked, so let me hit escape on the keyboard or just click in space to deselect. Okay, so let me hold on to the controller key again. Make sure you click the edge and not the surface. There it is, it's red, letting me know I picked an edge. And there it is again, red, so I've picked two edges. Okay, so now I can let go of the control key. And now I can click on the hole command. So here's the hole command. Alright, so click on hole command. And then click anywhere on the surface. And when you pick the surface, the hole will be created normal or perpendicular to that surface. Okay, so click. And it's hard to see, but here are the dimensions. There's the horizontal dimension. Let's change that to 0.1. My mistake, to 1 inch. 1 inch for the horizontal. And okay. See, it moved the hole over. So from this edge to the center, it's 1 inch. And then we have our other dimension. It landed all the way over here. It may not land in the same location for you, but here it is. Let me bring it out so we can see it. So this is 0.35. So let me change this. Double click. Change it to 0.35 and okay. And our diameter, so we can either change diameter. So here's the diameter, or we can just type it in here. So our diameter is 0.25 inches, so 0.25. And then depth. So we have the option of just going all the way through. We can either type in a depth. Hey, I want it to go 1/2 inch, 1/4 inch, 1/8 inch. Or you can just say, hey, I want this to go all the way through everything up to last. Go through the entire solid. So we can say up to last. So it'll go through the entire solid. Okay, let's get a preview here. And there it is, our preview. And I want you to be aware of that there's different types of holes, and the book covers this very well. So this is a very simple hole. So if we go to type, notice it calls it a simple hole. There's also tapered holes. Notice it tapers it. So it's a conic shape. There's also counterbored. That's when you have a small diameter hole followed by a larger diameter, but the larger diameter hole doesn't go all the way through. Okay, and there's also a countersunk. So right now the dimensions are fighting each other. The dimensions, the thing is, this is too thin, so it doesn't like the default measurements. But pretty much a simple hole, my mistake, a countersunk hole. It's a hole with the chamfer, if you look at it. And then we have counter drilled. And by the way, you can also define threads. Okay, so if this hole had threads, if it's a tapped hole, you can define it. Well, actually, we don't have I don't have this either. Probably you don't have it either, but typically you can download an Excel file with metric and inch threads that you have to put in one of your CATIA folders that this can go to, and you link it to the hole command. And you can say, hey, I want a 1/2-13 thread. I want a M8 8mm thread, for example, M8 or M6 6mm thread. Okay, so we're not going to cover that in this class, but just be aware of it. Okay, so I'm going to uncheck thread. We're just going to use a very simple hole, no threads. Go back to type. I'm going to use a very simple hole. And again, look at here at the preview. I'm going to keep it simple. extension. Go to the extension tab, and we have our diameter of 0.25, and we want it to go all the way through the entire solid, through last, right? So we're good. Measurements match. Hit OK. Click and space to deselect. You can always double click on the hole from the tree or here on the solid if you want to make changes. You can always double click and make changes. Diameter, horizontal dimension, vertical dimension, etc. Okay, so you can always make changes. Notice that the normal to surface is on. That's the default. So when it drills the hole, it'll go normal to surface. And 99% of the time, that's the way you want it. If for some reason you want to come in at an angle, which is very rare, you can uncheck this and pick an axis or something to give it direction. All right, so hit OK. Okay, so the next step is to create another hole on the other end. Same dimensions, so the instructions are to create another hole on this side. So let's pre-select the edges first. I'm going to hold on to the control key, click the edge of the chamfer, click the vertical edge. Okay, now I can let go of the control key, click on the hole command, click anywhere in space or actually on the surface. I'm going to really click like way off. I'll click somewhere over here. Okay, so just to show you wherever I click, that's where it places the center. Okay, so this is supposed to be 0.35 for the vertical, 0.35. Okay, and I don't see my horizontal. There it is. I know it's hard to see sometimes. There's the horizontal dimension. That's supposed to be 1. And our diameter is 0.25, and we'll have it all the way to last. And simple hole. First option, simple hole, plain hole, right? And OK. So there's our second hole. All right, so next step is to create a hole pattern. Okay, so instructions is to create a hole pattern. Hole pattern, I think it's 4 and 4 on the opposite side. Let's go back to the instructions. Okay, so we're going to learn how to use rectangular pattern. So here's the rectangular pattern. You got to look for this cube with 9 dots, right? And sometimes it's difficult to find commands. And one thing you can do is go to the drop down here, or my mistake, go to the bottom right corner, and sometimes you have to dig out toolbars. So if you don't see a command, most likely it's buried in the bottom right corner. So we're going to do a rectangular pattern, and let's take a look at the dimensions. Okay, so we're going to create a rectangular pattern of 4 with spacing of 1.25. All right, so we're going to take this hole and create a pattern of 4 as instructed per the textbook. Okay, so I don't see a hole pattern. If there's a command that you just can't find, and the textbook does walk you through this, you can always go to Insert and go down the list, and it gives you a few commands here, right? And these commands are actually buried in the bottom right corner, the ones that we don't see. Notice we have pad. We also have it over here, right? Docked over here on the right, this toolbar. So this is the sketch-based features toolbar, right? Which is this one. Okay, so if you ever have trouble finding a command, go to the drop down, Insert, Sketch-based features toolbar. There's dress-up features, fillets, right? We already created a fillet, chamfer. Surface-based features like split, or you can take a surface and give it thickness. And here are the transformation features. Here's what we're looking for. We're looking for rectangular pattern. Now the textbook does walk you through rotation, translation, symmetry. If you want, you can go ahead and play around with these translations or transformations. I'm going to skip them, but if you want to play with it, go for it. Okay, so here's rectangular pattern. There's also circular. Okay, so here's rectangular pattern. So if you don't find it listed on the right, you can always go here. But for those of you that want to use the icon, let me click in space, deselect. You can dig it out from this bottom right corner. So see this toolbar here? There's a little handle. I know it's hard to see, but there's a little gray dash that allows you to pull out toolbars. And there it is. Now if you want, you can start a second column of toolbars. You have to just be careful. There it is. And now I've created a second column of toolbars. You can keep digging out toolbars if you like. I'll leave it up to you. And there's more, as you can see. Okay, we can move these up. So at work, I tend to pull these toolbars out, so I don't have to go in digging for them and looking for them. Notice there's no more downward arrow, so we pulled out all the toolbars that were buried here on the bottom right corner. And there's also horizontal ones, by the way. So here's the horizontal ones. As you can see, there's a bunch of them. Alright, so it looks like we've taken everything out. You can always double click at the top of the toolbar to dock it back in. It's going to just hide it. Double click. Don't click on the X, but on the white area, double click. Again, don't click on the X or else it'll close that toolbar. Double click, so it buried it back in the right corner. Alright, so let's go ahead and use the rectangular pattern command. So here's the rectangular pattern command. You can always pre-select the feature you want to pattern. You can select more than one. In this case, we're only going to do one feature, which is hole number 1. So I'm going to pre-select it. Go to rectangular pattern. Click it. Alright, so I want you to notice that we've already picked hole number 1. And as mentioned before, when we did fill it, if you click on this little bag, you can pick more than one. So this is your bag of all your choices, right? We only have one, which is hole number 1. You can add more if you like. So that's a little bag with all the geometry you want to pick to apply this command to. In this case, we're only doing the one, so I'll go ahead and close this. Alright, so we're going to do a pattern of 4 instances. So we're going to go with instance and spacing. There's more options. We can have instances and length. So we can have, let's say, 4 holes over a length of 1 inch, and it'll evenly spread them out within that 1 inch. Or we can say, hey, we want 4 instances at a space of, let's say, 1/4 of an inch apart. Okay, and that's the one we're going to use. So there's other options here. So we're going to go with instances and spacing, the second option. Let me just double check. Yep, we're using the second option, instances and spacing. Okay, so instances and spacing, the second option. Okay, and we're going to increase this to 4. We can either highlight this and type in 4, or we can always click on these little arrows to increase. Or we can always type it in. Type in a number. Oh, let me backspace. I meant to type in 4. So we're going to use an instances of 4, spacing of 1.25 inches apart. Okay, so in spacing, I'm going to click in here, hold on to the left mouse button and highlight, and I'm going to change this to 1.25. All right. Now we need a direction. So which way do you want to go? So we want to go horizontally. So we can now select here to populate. So notice this is now blue. So it's waiting for us to populate the direction. So we can say, hey, we want to go in this direction. Anything going horizontally is acceptable. So we can say, hey, I want to go in this direction. Notice it's going in the wrong direction. I want it to go inward, so I'm going to click on reverse. There it is, it flips it. Now we only need one row. If you wanted to add a second, third, or fourth row, you can always say, hey, I want a second row. And you can increase, let's say, to 2. Preview. Oh, my mistake, I forgot to give it a direction. Okay, so we're not going to do a second or third row, but I just wanted you to be aware that you can do a rectangular pattern horizontally and vertically. We don't need 4. I'm just going to drop this. Again, we're in the second direction tab. I'm just going to drop this back to 1 and click on the first direction tab. Okay, and we have 4 instances at 1.25 inches apart. Also, instead of selecting an edge like we did for direction, so we had chosen this edge. Oh, my mistake, I clicked in the wrong area. I meant to click here. So we had selected this edge, right, for the horizontal. Another thing you can do instead of picking a solid edge is I'm going to left mouse click first to highlight this. It'll turn blue, so it's waiting for me to populate the blue box. Then I can right click and I can pick a direction. I can say, hey, I want to go in notice here, this is the Y direction for us. I can go in the X direction, Z direction. So you can pick from here. So all I did was inside this window, I right clicked and this pops up. I can say, hey, I want to go in the X direction. Notice it's going here in this X direction, which actually we don't want to go in this direction. There's the X. Let me left mouse click, turns this window into blue. Now I can right click and say, hey, I want to go in the Y direction. Now it's going correctly in the Y. What happens if I go with Z? So Z is like, hey, can I go in Z direction? There's no solid. Okay, so let's go back to, when left mouse click, turns blue, right click and say, hey, I want to go in the Y direction. That's the direction we want to go. Y, you can see here by the tree, or my mistake, the compass, also referred to as the robot. And okay. All right, so I didn't mean to have it generate XYZ directions. Let's see if I can delete this. Actually, when I was playing around selecting the Y, the Z, it auto-generated these options, or these axes, which we actually don't need except for the Y, and I didn't mean to do that. So let's see if I can delete the Z. Yep. Delete the X. I don't think I can delete the Y. Let's see what happens if I delete the Y. Oh, it did work. Okay, so again, because I didn't pick a solid edge, I went with an axis. It auto-generates this for direction. If I was to delete this, it's saying, hey, it doesn't have a direction. So okay, but if I was to go back to the rectangular pattern, and instead of using the Y-axis for direction, and I use an edge, I will no longer need that line that it populated in the tree. So it dumped it out. So originally it was underneath. Once it's no longer needed, it dumps it outward, away from it. Okay, so I no longer need this Y-axis. All right, so we're going to do the same thing for the opposite side. So I'm going to pre-select this hole. Oh, I meant to pick the entire hole, not the edge. There it is. And let's do the same thing, rectangular pattern. By the way, there's circular. There's also a user pattern that you can create a bunch of points on a sketch. We'll use those later. I'll demonstrate it in a later video. Okay, so let's go rectangular. And it remembers the last numbers I used. 4 instances at 125 apart. And for direction, so left mouse click, it turns blue. Direction, follow this edge. And again, you can always hit the reverse button if it's going in the wrong direction. There it is, and hit OK. Alright, so next thing we're going to do is we're going to mirror this and create a T extrusion. We're going to mirror. Okay, so for the mirror command, here's mirror. So mirror will create a double on the opposite side of whatever plane we choose. Don't mix it up with symmetry. Symmetry will do a mirror image of the solid but get rid of the original. Okay, so be aware of that. Let me rotate this. Alright, so here we go. We're going to use the mirror command. Mirror. And it needs a plane or a flat surface to mirror about. So if I was to pick this surface, notice it gives me a preview. It starts mirroring it over to the other side. And let's hit OK. And there's our T extrusion. Okay, so once again, be aware that when you use mirror, it mirrors, in this case the L extrusion, it mirrors it over. And it keeps the original. If you were to use the symmetry option, notice how it's hard to see, but this is grayed out. So what it does is it'll hide the original source and only give you the opposite L. Okay, be aware of that. Difference between mirror and symmetry command. And if you don't see the icons here that the command you're looking for, once again you can go to insert. In this case we're using transformations. Okay, so here's symmetry, and we actually ended up using mirror. And here it is on the tree, mirror. Let me click in space. So we used our mirror. Alright, so let me double check. By the way, if you have more than one window open, or two files open I should say, you can always go to Window, Show Me All Files, line them up vertically. See that? Well, looks like I created the holes in the wrong. Actually, I mirrored about the wrong surface. I was supposed to mirror about the other surface. Okay, so my mirror, I used the wrong surface to mirror about. Notice the holes here are on the flanges. Okay, so let me go back and fix that. And then we're going to add a... Actually, no, this fill is already there. Okay, so let's fix that. So let's go back. So I can maximize this window. So once again, let me fix that mistake. So go back to mirror. All I have to do is double click. And I also am supposed to actually mirror from this bottom surface. Not the top flange, but the bottom flange here. Okay, there it is. That's a lot better. And okay. Okay, so I had chosen the wrong surface. Alright, so there's our part. Let's do window vertical just to check it. Make sure everything looks good. Yes, everything looks good. Looks just like the one on the right, the completed one. Alright, so let's go back. So I'm going to click on this window. Notice the frame is blue. So anything I do next, it'll apply to this one. If I click in this space, this will turn blue, and any commands I use will apply to this part. Let me go back to this one. I'm going to hit the maximize. Alright, so if you wanted to add color to your part, you can always right click on the part body. Right click properties. You can go to graphics tab. And the first one is for surfaces. Second one is for edges. Third one is for points. So we're going to change the color of the surface. This is optional, you don't have to do this. So if I wanted to make it blue, for example, it'll change all the surfaces blue. Notice the edges, the default is black. Points are white. Okay, so here we go. Okay, there it is. Clicking space to deselect. So there it is, blue. It's a little too dark. Let me change this to a lighter blue. Right click properties. Instead of this dark blue, I'll go with the lighter blue. There it is. Okay, another thing that the textbook walks you through is on how to add material. Okay, so when you get this part made, you ask a machine shop to make this part for you. You need to tell them the materials. It's made out of wood, steel, aluminum. So I'm going to go with aluminum as instructed by the textbook. Okay, so look for this icon. It looks like a rubber ball bouncing into a box. So we're going to apply material. Click on apply material. Okay, and we have the metals tab. Look at all these options that we have. I'm just going to go straight to metal tab and apply aluminum. Aluminum and steel are the most common one to pick. So I'm going to go with aluminum. And then I need to apply it to something. Okay, so notice here on the bottom left corner, it's telling me you have to select. Well, select what? You need to select the solid. So I'm going to select the entire part body. And then I can apply it. So this was grayed out because I had not told CATIA what I wanted to apply material to. Sometimes you may end up having multiple part bodies. And I'll explain that in a later lecture towards the end of this class. Okay, so now we can apply material. And notice it added aluminum. And here we can click OK. So now by adding aluminum, we can now find out the weight. So now that CATIA knows what material you have applied, you can actually find out what the weight is by clicking on measure inertia. Click on it, select the object you want to measure its weight, click on it, and notice it tells me it weighs 0.191 kilograms. If you want pounds, you can always go to tools, options, same location where you change your units from inches or millimeters to inches and vice versa. All you have to do is go to the mass section, and instead of kilograms, you can switch it over to pounds if you like. And here's the density. It's giving it to us in kilograms per meters cubed. If this was in inches, pounds, it would be 0.098 pounds per inches cubed for the density of aluminum. So the cool thing is, when you add material, it brings in the properties of that material. I'm going to go ahead and just cancel this. If I double click on aluminum, double click on it, it gives you its properties. So let's see, I think it's analysis. Here it is. Here are the properties of that material. Poisson's ratio, density, its coefficient of thermal expansion, its yield strength. Okay, so those of you that have taken stress analysis, this will look very familiar to you. And in CAD 33, we do cover, at least spend some time on covering stress analysis, an introduction to stress analysis, and how the part behaves when you add a load to it. For example, let's say this is cantilevering out, and you applied a load to it. It's like a diving board. And it's going to analyze the part for you, let you know how much it'll bend or when does it break based on the dimensions of the part, the location of the load, and based on the material that you're using and its properties. All right, so I'm going to go ahead and just cancel this out. Okay, another thing the book walks you through is, let's say you wanted to go back in time. You wanted to see, how did you make this part? How did you make this part? So you can pre-select the part body. Go to edit. And you don't need to do this part, but the book walks you through, hey, if you want to find out the history of how this part was made, go to scan. And we can go back in time to the beginning, right? So if you click here, it'll take you to the beginning. Okay, you started off with an L extrusion. You can play all the way through, or you can just click next. What was the next thing we did? Well, you added fillets, right? The rounds. And what's next? Oh, you added a chamfer here at the bottom edge. There's the chamfer, right? Notice how it goes down the list, it underlines it. Next, you added a hole, right? Next, you added a second hole. Next, we did a rectangular pattern. Next, a second rectangular pattern. And finally, next, we did a mirror. Okay, so that's how scan works. So we go all the way to the end. Play, it goes all the way to the end. Okay, since I'm done, I can go ahead and close this. You can also do it manually, by the way, so you don't have to use scan. I never use scan. If I need to go back in time just to see what it looks like, what I do is right click on the feature, right click, define. See, it goes back in time. See how it's underlined? Okay, what was next? Right click, define, and there's the fillets, right? And if I just want to go all the way to the very end of the story, I can always right click on the part body, define, and it'll take me all the way to the end. Notice now the part body is underlined, so it brings me back to the present. All right, so now all we have to do is save this. Okay, so we still have the original L extrusion saved as a separate file. So currently this is the L extrusion. If you look up here on the bottom, on the upper left corner, it tells us, yeah, this is currently the L extrusion. But let's say we wanted to keep the original L extrusion and now save a second copy as a T extrusion. So I'm going to go to File, Save As. So I still have the L extrusion. Now we can save this as a T extrusion. So you have the new file, T extrusion, while still keeping the original L extrusion. Okay, and I'm going to save. And later on, we're going to, towards the very end, the last 2 weeks of class, we're going to go over drafting. We will create a drawing from this part. So make sure you save your part. Make sure you remember where you saved it, whether it's on the flash drive, on the cloud, or on your desktop, because we're going to come back later on at the end to create a full drawing of this part. Okay, let me just go back, make sure I didn't miss anything. Oh, one thing I did miss is the book does walk you through, hey, what happens if you change the sketch? What happens to your part? What if you change this 1 inch length to 2 inches? Okay, so let's go ahead and walk through that. So if we were to go back to sketch 1, double click and change this length. Instead of 1, change it to 2. What happens to the part? And hit OK. Now it should turn red as it's updating to this new dimension. And OK. Notice the yellow swirls. The yellow swirls are telling us, hey, it's going to impact and it's going to be changes. So notice how this is a lot longer now. So when I exit the sketch, it's going to turn red and update. See, it was red. See, now this is a lot longer. It's 2 inches in length, right? You can always hit undo if you like. Or we can always go back to sketch 1 and change this 2 back to 1. All right, let me just double check again, make sure I didn't miss anything. Now the book does walk you through a lot of other stuff like rotating, translating, and I'll cover that in a separate video on how to use these commands. Just want to keep this command short. Oh, another thing I did forget is it shows you how to scale down or up. So it does ask you to scale off of this point, scaling it down to half size. You don't need to do this part if you don't want to. I'm just going to walk you through it real quick. Okay, scale. So sometimes you need to scale things down. So here's the scaling command. If you don't see it here on the right, you can always go to the insert and look for it. So here it looks almost like a exploding star, as you can say. Alright, so I'm going to scale. We need a reference point to scale about. So it tells you to pick this point. If you want to pick a different point on the part, go for it. Click. Let me zoom out a little bit. So I can pull on this green arrow to scale it up, so you can see, or scale it down. So you can use the green arrow, change the size, or you can type in a scale. So I'm going to left mouse click, hold and highlight and change this to 0.5. And okay, notice how it changed it to half size. I can always deactivate this. Let's say I want CATIA to ignore this. Like, let's say we want this to be dormant. We can deactivate it, but we don't. Let's say we don't want to delete it, but we do want to turn off this feature. You can always right click, go all the way down to scaling, go to deactivate, 3, 2, 1, click. Notice it took the scaling to place these red parentheses around it. So it lets us know that, yeah, we have scaling, but it's been turned off. It's been deactivated. Okay, so I can always reactivate it. Right click, activate, 3, 2, 1, there it is. Okay, so I'll leave that up to you if you want to scale it or not. I'm not going to take any points off if you don't. Alright, so let me go ahead and save. I know I already saved it as T-Extrusion, as you can see here. It's already saved. So I'm just going to go ahead and go to File, Save. Or you can click the disk here. And it saves it. Alright, that's the end of this video. See you in the next one.